Alrighty, ladies and gents, this is O27 Notes on Integers and Order of Operations, aka I just wrote PEMDAS, which we'll learn more about in a minute. Objectives: you'll be able to demonstrate your ability to solve algebraic problems, you'll be able to simplify an expression, and you'll be able to solve one-step equations. Alright. So as you already know, through the emails, but I want all you guys to be able to sign into the Google Classroom, and there's a shared document with portfolios so you could track and document and write down how you feel about each evaluation, what you liked about the test, what you didn't like about the test, what you had trouble with, what were your strong points, weak points, and you can reflect on where to grow. So first thing I want you guys to do is hit the pause on the video and to complete the Algebra 1 pretest. I just want to get an idea of what you already know and what you don't know as a teacher, so I know exactly where you're starting from and I can build you up from there. Alright, so first thing I want to talk about is all the different types of numbers there are and that we acknowledge as mathematicians. There's this concept of real numbers, which includes all the numbers that you've been learning about so far in your school. There's also called numbers that are not real numbers, which you're going to talk more about in Algebra 2. But for right now, we have the whole concept of real numbers, and that's everything you know. And then inside the concept of real numbers, there's irrational numbers, and there's rational numbers. And a smaller set of numbers is integers in those rational numbers. Then there's also whole numbers that are a little bit smaller. And then there's natural numbers. Now we're going to break this down a little bit further in each concept. Real numbers, in that section of real numbers, we have this thing called natural numbers. Now natural numbers is the smallest group there. Natural numbers are the numbers that were used to count when you first learn about math. That's when you're counting on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, etc. So it was up and up and up, starting at 1. Those are the natural numbers. Next up we have whole numbers, which is that same group of natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, it also includes 0. And that's the difference between whole numbers and natural numbers. Whole numbers have the 0 in it. Next up is integers. These are numbers that you've seen a lot in your life. You have 0, 1, 2, 3, 4, 5, 6, 7, 8. So it includes the whole numbers, the natural numbers, and it also includes the negative values of the natural numbers. So like -1, -2, -3, -4, -5, so on and so forth. So these are integers, are the numbers without any decimals. They don't have any decimals whatsoever. Rational numbers. That includes the decimal numbers like 6.2, 12.5, 4.25, 1/8, and it has an endpoint. So it means we could also change this decimal into a fraction. So when decimals have an ending, it stops after a certain amount of decimals. We could turn it into a fraction. That means it's going to be a rational number. Irrational numbers are the decimals that never stop. It just keeps going on and on and on to the right. Now there's a symbol that represents one of these numbers that you might have heard of before. You might have heard of 3.1415 ... or 3.14 ... a whole bunch of numbers. Can you remember that symbol? If not, I'm referring to pi. Pi is equal to 3.14 ... And it just keeps going on and on and on. Alright, since we talked about the few, let's practice a few, identifying them. This is a little table, a little chart, and all we're going to be doing is filling in the bubbles to identify if it is in that category. So let's focus on the number 7.5. Well, is 7.5 a real number? You bet, it's a real, so we click on that dot. Is it a rational number? Yep, it is rational. Is it an integer? No, it's not. Since it has a decimal, that means it's not an integer. It's also not a whole number. It's not a natural number, meaning like you could count on your fingers. And it's not an irrational number. Because irrational numbers go on and on and on. Because remember, they're on their own little separate category. Alright, so radical 2, square root of 2. It is a real number. Now if we type in square root of 2 on our calculator, so we do second square root, put in 2, close parentheses, we get 1.414213562. Now, these numbers go on and on and on. There's no repetition, there's no pattern, it never ends. So it turns out square root of 2, it's an irrational number. Doesn't have an endpoint. Pi is 3.14. We already know that's a real. It's also irrational. -6, it's a real number. It has an endpoint, so it's rational. It's also an integer. However, it's not a whole number, and it's not a natural number. So that's what those charts are looking for, or asking for, when you see those in the homework. Alright, we could also combine all these types of numbers in different ways. We could add them, which you already seen, that's that symbol. You could subtract them, that symbol. Multiply them, which is a dot. Or growing up, you would also see an X as a time symbol. Divide by, you've seen a division sign like that before. Division also could be represented as a slash. Square root, you've seen those radicals before. You've also seen them maybe with a number or 2 sitting on that bench. This is a cube root. Square root is when there's nothing there on the bench or 2 on the bench. You also seen powers. You have something in the base, and you have a 2 in an exponent, or maybe a 3 on that y. The numbers in the upper little right hand corners, those are the powers. So now, we want to make sure we calculate problems very carefully, especially with our signs, when we're adding and subtracting integers. When you have 2 negatives in a row like this example, 5 minus parentheses a minus 2, close parentheses, these two negatives in a row really make a positive. So this is really saying 5 plus 2, and 5 plus 2 is 7. In this one we have 9 minus a positive 8. Well, when you have a minus and a plus sign, that's really just a minus sign. So plus minus turns into a minus, so 9 minus 8 gets us 1. And you could use a number line if you have some trouble here. So if we start at 9, and we subtract a positive 8, 2, 3, 4, 5, 6, 7, 8, you see you wind up at positive 1. Alright, let's look at these. 6 minus a negative 10, well, 2 negatives make a positive, so 6 plus 10 gets us 16. 8 minus a negative 15 is really 8 plus 15, which gets us 23. 24 minus a negative 11 turns into 24 plus 11, which is 35. 18 minus a negative 28, well, negative and negative turns into a positive. So 18 plus 28 gets you 30, 46. Once again, you could use a number line to help guide you along. So now if we have a positive and a negative, well, if you have one of each, that turns into a negative sign. That's, remember, when it's back-to-back symbols. So 7 minus 2 is 5. This plus sign is followed by the negative sign. So plus minus, that really is a minus when you're working with two numbers, and inside the parentheses all simplified down. So 11 minus 60 gets you negative 49. This positive 14 doesn't need the parentheses because it's already simplified down, so negative and a positive turns into a negative. 30 minus 14 gets you 16. 24 minus a positive 34, the minus and a plus, turn into a negative, so 24 minus 34 gets you negative 10. Now when these get a little harder, you can handle it still. Just take care of all the signs first. So 17 plus minus, well, plus minus turns into a minus. So 17 minus 4 gets you 13. This is a plus minus, so you change that into a minus. Two minuses make a positive. These two pluses stay a positive. These two minuses turn into a plus. Now once you take care of all the signs, then you gotta go from left to right. So 17 minus 4 got you 13. 13 minus 6 is then gonna turn into 7. 7 minus 13, I just cross them out. That's how you use them. So 7 minus 13 gets us negative 6. So I just subtract that 13. Negative 6 plus 3 gets us negative 3. Negative 3 plus 1. Well, negative 3 plus 1 gets you negative 2. And negative 2 plus 52 gets us to 50. So after we combine everything, it turns into 50. Let's try another one of these tougher ones. Slide it up from more room. So plus and minus turns into a minus, so I change that to a minus sign. The minus sign, well, that doesn't have any other signs, so we don't have to combine anything. This has a plus and a minus, so that changes into a minus. These two minuses in a row, that turns into a positive. These two positives, that remains a positive. And these two negatives turn into a positive. So 24 minus 7 gets you 17. 17 minus 16 gets us 1. 1 minus 43 gets us negative 42. Negative 42 plus the 13 gets us negative 29. Negative 29 plus 21 gets us negative 8. And negative 8 plus 12 gets us positive 4. That's how we're going to get an answer of positive 4. Let's do another. Plus and minus turns into a minus. This plus and minus turns into a minus. These two negatives turn into a positive. Two positives stay positive. And these two negatives turn into a positive. Why don't you try this on your own? Combine them out. Now this one is your answer. Why don't you try this one completely on your own? Alright, moving on. Order of operations. Order of operations is important. Just like putting together a peanut butter and jelly sandwich. You can't just take out the peanut butter and add the peanut butter and the jelly together first and then put the bread. You first have to lay out the bread. Then you have to either put on the peanut butter and then put on the jelly and then put your last piece of bread on. So there's lots of little steps to making a peanut butter and jelly sandwich, and you have to do them in order. Well, for some parts you have to do in order. you can get creative to make it a nice, clean peanut butter and jelly sandwich. This concept also applies in mathematics. There's an order to math that we have to follow. And that order has a simplified name called PEMDAS, where P stands for parentheses, E stands for exponents, M stands for multiplication, then division, then addition, and then subtraction. Sometimes M and D could be interchangeable, and so can A and S. But everybody says it in this order because it's a nice little acronym. Help you remember PEMDAS. So number 1 here, we have 7 times negative 7, parentheses, parentheses again, negative 14, close parentheses, plus 15, close parentheses, minus 2. We first have to take care of what's inside the parentheses. This negative 14 has been simplified, so negative 14 plus 15 gets us negative 1. So we have a negative 1 on the inside of those parentheses. I could actually erase this now because we simplified that. Now, we have, I'll write it out nice and pretty, so it'll be 7 times negative 7 times negative 1 minus 2. Now, we took care of the parentheses. There is no exponents. Now we have to deal with multiplication and division. So we go left to right. 7 times negative 7 gets us negative 49. Negative 49 times negative 1 turns into positive 49. And then 49 minus 2 gets us 47. And that's our answer. Let's do another one here. So PEMDAS, we have to take care of all the parentheses first. So everything that's on the innermost parentheses. So we got this whole big thing here. We have to take care of that first. And then within that, it looks like we have another one right here. So we have to do negative 19 plus 5, which gets us negative 14. So that's in that one set of parentheses. Then it's the minus sign from here. And then we have to take care of this. Negative 38 plus minus, which turns into a minus. So negative 38 minus 28 gets you negative 64. Let's get PEMDAS out of the way. So negative 64 minus a negative 14 turns into a positive. So 64 plus 14 turns into 78. So we have 78 divided by negative 4. And that turns into a decimal there. So it's going to be 19.5. Alright, let's squeeze in this last one here. So we have a set of parentheses here. So negative 12 minus 8 gets you negative 20. Then carry down that division. 8 minus 3, that's also can be simplified inside that parentheses. That turns into 5. And then a plus 3. According to PEMDAS here, took care of the parentheses. There is no exponents. We gotta do multiplication. Well, there is no multiplication. So next up is division. Negative 20 divided by 5 gets us negative 4. So division is taken care of. Then addition. So then plus 3. So negative 4 plus 3 gets us negative 1. Here's your classwork and your homework. If you have any questions, feel free to email me. Everything is found in Google Forms in our Google Classroom. So email me or come to Extra Help. I'll be happy to help you out. All right, have yourself a good night.